Here, we will discuss one of the major issues with test automation and how to overcome them with TestProject. Flaky tests are inconsistent tests, sometimes pass and sometimes fail. Flaky tests can be quite time-consuming and difficult to deal with, often requiring retriggering entire CI builds. Let's talk about the reasons for this flakiness. One reason are false positive actions. In some cases where your action reported successful, but in reality didn't achieve their desired outcome. For example, a click or a tap that happened while your page was still loading. The click was successful, but nothing else happened. Another reason might be asynchronous web events. In some cases, server-side events are asynchronously generated and appear on the screen. It can affect your UI, and since automation depends on the UI, it'll break it. Another reason can be device variations and configurations, high-cost versus low-cost devices, different operating system builds on the same platform, different visualization and execution speeds, internet connection speeds and loading times, as well as server-side speeds, can be a very big enemy for automation. The most major cause for flakiness is changes in your application's DOM. These changes can result from dynamic UIs with dynamic IDs and elements, or changes made by the development team during the application's lifecycle. The TestProject platforms offers various tools to improve your automation for web and mobile applications. In this video, we'll show you how to tackle these issues in your tests and what tips and tricks you can use. But first, let's discuss the AI tools that TestProject provides to handle those issues. For false positive, TestProject has the automation assistant that'll analyze each of your tests and detect when the action didn't reach its target goal. It'll attempt to fix it automatically for you. The second tool is the adaptive wait, a mechanism that will ensure all conditions are met so that the automation succeeds. It is very useful for different loading times and network connection speeds. The third powerful feature is the self-healing. It'll automatically construct a variety of locator strategies that can be used when others fail, meaning all web and mobile elements are located by multiple locator strategies when your UI changes or is dynamic, or the application changes through the development lifecycle. Now let's deep dive and see an example of how to reduce flakiness in your tests. Let's create a mobile test to see how the TestProject AI tools help you to reduce flakiness in your automation and improve your Appium codeless tests. Let's choose a real-world application that is installed on my mobile device to demonstrate how it works. The TestProject agent will detect my connected device and show me all my installed applications. As mentioned, I currently just have my Android device physically connected to my Windows machine and the TestProject agent running in the background. The TestProject agent will take care of setting up a new Appium session for me, so I don't need to install any additional dependencies. The first step created in any mobile test is the reset app step. We can use this to reset our application to its original condition. Now that our application data is clear, let's create a test flow by interacting with the application and going through different screens and interacting with different elements. What I'll be doing in this test is navigating through the application's menus, performing a search, and then interacting with a few more elements. It's important to mention that the application we're using now is actually a hybrid application with many web views, showing that using the TestProject Recorder, you can even automate the most robust of applications. Let's start wrapping up our test. As you can see, we've created quite a complex flow here with 12 different steps. Now that we're done creating the test, we can take a look where the AI tools are located. After heading to the test settings, we'll be able to find the adaptive wait feature. As mentioned previously, the adaptive wait helps reduce flakiness in your test by waiting for your entire application's environment to be ready. It won't wait the entire duration, it's just a maximum threshold. Even if we increase it, it won't slow down your test. Here, we can also find the automation assistance, which will identify scenarios where the expected step didn't happen and will attempt to fix them automatically for you. It is always on by default. The TestProject Selfhealing AI comes into play when you interact with elements. Each time you interact with an element, it's identified by multiple different locators. So if your application changes shape during the development lifecycle or has dynamic layouts and elements, the element will still be located. You can of course reorganize these locators and even add your own if you want to. Now, let's run our test from the beginning to see how the TestProject AI helps stabilize our test and reduce the flakiness. Here we can already see a good example of the adaptive wait coming into play while our application is still loading. Here, once again, we can see the TestProject AI stabilizing our test. Without this stabilization, using regular Selenium or Appium, the test might have already been failed several times. Once again, the recorder is using the adaptive wait feature to wait for your application to reach the correct state before continuing on with the test. As you can see, our entire test passed. But what if we didn't have these tools? Let's disable the automation assistance and then run the test once again. The recorder will still use the adaptive wait feature to stabilize our test, but without the automation assistance, something unexpected might happen during the execution. As we can see here, the test is attempting to be stabilized, by this time without using the automation assistance. As you can see, without the automation assistance, our test just failed. Let's rerun the test, but first, let's re-enable the automation assistance. In addition, let's demonstrate the self-healing capabilities by purposely breaking one of the locators in one of our element-based actions. Now, let's once again run the test to see how these free tools that you get straight out of the box help you in the background by stabilizing your test and reduce flakiness. Once again, we can see the adaptive wait performing and stabilizing the test while the application is loading. Here we can see the automation assistance stabilizing our test's execution. As you can see now, self-healing is being performed on that element which we broke the locator of earlier. the step was healed, but now we'll see the next step is going to be healed as well, since both the steps are using the same element. If you're executing outside recording mode, the element will be updated, so no further executions of a test will require self-healing. Now, after the execution, we can see a notification that self-healing was performed, and we can also notice that using automation assistance, our entire test passed. Now, let's once again understand what is a flaky test. It is a test that passes and works while recording, but during execution fails, or sometimes passes and sometimes fails. The flakiness can be caused by differences on the devices you use to record on, internet connection speeds, and anything else we've talked about at the beginning of this video. Let's go over the tips and tricks you can use while working with TestProject to reduce test flakiness. The first thing you can do is increase the adaptive wait time. As mentioned earlier, it won't slow down your test at all, it's just a maximum threshold. We recommend 45 seconds. The second thing you can do is make sure your automation assistance is turned on. As we've seen in this video, it can help dramatically reduce flakiness. If you still experience flakiness, the third thing we recommend doing is reducing the overall execution speed. Some applications are not built for fast automation and behave better under human speed interactions. We recommend slow or even turtle slow. If you change the adaptive wait time or execution speed at a test level, please make sure you didn't also change it at a step level. Otherwise, the step level is the value that's going to be used. If you still experience flakiness at a certain point in your test, we can also recommend using validations. The reason we recommend these validations is because the validations use the TestProject adaptive wait feature. The validations will act as checkpoints, ensuring your application is in the correct state before your test continues on. You can use any validation on any kind of element during any point of your test.